Well, hello, third graders. Welcome to lesson number 7 in your math program. And in this lesson, we're going to be thinking about fractions, of course, more fractions, making sense of fractions. Do you see this figure here? It looks like a cup, right? At least it resembles a cup. Imagine that if the cup were filled up to here, we'd call that the whole thing, okay? And imagine that we poured some liquid in to this cup, and the liquid went to about here, right? And then we would ask ourselves, well, if the liquid is going to about here, well, what fraction, or about what fraction of the cup is full? And you and I might look at it and say, well, there are 2 equal parts, and one of those equal parts is full. So we might call this 1/2, right? And to look at that as a unit fraction, we'd say 1/2. 1/2. That's the fractional form, and this is the unit fraction form. Okay? Now, what fraction is not full? What's empty? Well, it appears to be the same thing. This one is unshaded, it's empty, and so we would also say 1/2 is empty, right? There's nothing there. And we could say that again in the unit form, 1/2. 1/2 is empty and 1/2 is full. Here's the big idea. If we take the half that's full, right, and we add it to the half that's empty, right? What do we get? We get the whole thing, right? Because this fraction plus this fraction is equal to the whole. And we could say it like this. This is a statement, right? An expression. 1/2 plus 1/2 equals 1 whole. We could also say it like this. 1/2 plus 1/2 is equal to 2 halves. Yeah, which is equal to the whole thing. Or we could say is equal to 1. This is a big idea. And we call big ideas in math, sometimes we call them concepts. Anyway, that's the big idea. And we'll be working with this over and over again today in a way that I think is fun. Let's take a look. This is similar to what you have, but mind you, you'll be looking at something called the problem set, and I'm looking at something called homework. So they're similar, but not the same. Let's look at how we'll do them. I'm going to ask you to do these in a certain way. And as always, just hoping that our machine can focus for you and me. Whisper the fraction of the shape that's shaded. You know, besides whispering it, I want to write it. Well, let's see. One part is shaded. And how many equal parts are there? 1, 2, 3, 4. So we can call this 1/4. Whisper the part. Well, 1 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it appears to be 1/10. 1 out of 2. Got the hang of it? 1 out of 3, 1/3. 1 part out of 1, 2, 3, 4, 5, 6, 7. How would we say that? 1/7. Good. I hope you're saying this out loud. Right? 1 out of 1, 2, 3, 4, 5. We must include them all. They're all equal parts. So 1/5. 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wow. 1/11 here. 1/11. And finally, 1 out of 1, 2, 3, 4, 5, 6. 1/6. Here's where it gets interesting. Then, it says in the instructions, match the shape to the amount that is not shaded. So in this first one, if one part is shaded and the fraction reads 1/4. Then what part is not shaded? Well, what's not shaded are the 1, 2, 3/4. So where can we find 3/4 here? We're scanning with our eyes, looking for 3/4. Aha! 3/4. So we connect it. 3/4 gets matched up with 1/4. The shaded part plus the unshaded part is equal to the whole thing. The whole thing, it's equal to 4/4, right? Shaded plus unshaded equals whole, a fourth thing. So, one more as an example. This is 1/10. So what part is unshaded? If 1/10 is shaded, how many are unshaded? You're probably thinking it's got to be 9, right? 9/10. Where can we find it? 9/10 goes with 1/10 to equal 10/10, which is equal to 1. And there's the idea of today's lesson, all right? One part plus the other part, the shaded part plus the unshaded, is equal to the total, right? The whole. So that's part of your exercises today. Let's just take a look at the other part of what we'll be looking at. We can also look at these strips, and the strips can represent the fractions too. Write a fraction. Sorry about the focus. You know the routine, right? Write a fraction to label the shaded and unshaded parts. Oh, look at here. You see underneath this strip how part of it is separated and then this part is separated? Well, let's write the fractions for the shaded and the unshaded. Well, this looks like 1 out of 1, 2, 3, 4, 5. 1 out of 5 we would call 1/5. How about the unshaded? 1, 2, 3, 4. 4 of them are unshaded. Out of how many? 4 and 5. 4/5, right. There we have it. How about here? One part is shaded. 1 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my goodness. That represents 1 out of 12. We can write it as a fraction like that and say it as 1/12. Well, if 1/12 is shaded, we know there's 12 altogether, 12 equal parts. How many are unshaded? If you're thinking 11, I think you've got the idea. If you need to count them, do it. Prove it. They're there, right? They're there. 11 of them are unshaded. So we can put those together. If we stuck them together as an equation, 1/12 plus 11/12 is equal to 12/12, which is equal to the whole strip. One whole strip. That's the whole. Finally, making sense out of problems with story problems, let's do one of these. Let's do Jerome here eating and cooking his oatmeal for his family. Jerome cooks 8 cups of oatmeal for his family. They eat 7/8 of the oatmeal. What fraction is uneaten? Draw and explain. Well, they say draw. Good thing. That's what we're going to do anyway, because when we do problems like this, we do RDW. It's our habit. It works. Let's do it. If Jerome cooks 8, let's show 8. I'm going to stick them right next to each other. Try to make them the same size. 1, 2, 3, 4, 5, 6, 7, 8. Okay, those are the 8 cups. They eat 7/8 of them. Well, let's show that. I'm going to show them with another color. 1, 2, 3, 4, 5, 6, 7. All right. That's what they eat, right? I'm going to even label that. They eat 7/8. See how that drawing just kind of shows what's going on? Then you can kind of see the answer. Look what fraction is uneaten. Oh, it's 1 cup. Out of how many cups? 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8. So we can make a statement, 1/8 is uneaten. And we've made a high quality answer with a drawing and with a statement. By the way, I love this idea. This is the big idea. 7/8, the eaten part, plus the 1/8, the uneaten part, equals what? 8/8, which is equal to the whole thing. That is, every single thing that Jerome cooked is the whole thing. Right? All right, best wishes today. So long.